All right, let's continue graphing exponential functions, but this time let's talk about what happens when we add a number to the back of my function or even subtract a number to the back of my function. So we talked in our last video about graphing f of x equals 2 to the x, but what do you think happens to our graph if we then add 3? Or we talked in the last video about graphing 1/2 to the x power. What do you think happens if we subtract 5? What do you think those numbers added or subtracted to the back of my function do to my exponential graph? Well, let's look. Let's go ahead and graph these two, and then we can compare them to the original to see how that positive 3 plus 3 or negative 5 minus 5 affect our graph, maybe shifting it, right? So we're going to do a table of values, just like we did before, where I'm going to pick some x values, plug them into my equation, figure out what my y value is so I can plot a couple of points and see if I can find a pattern. Let's start with example number 3. Let's evaluate f of negative 5. I'm going to plug in negative 5 for my x, and I end up getting 2 to the negative 5th power plus 3. Now remember, negative exponents don't make sense, so we have to make them positive first. We can drop that down. We can figure out what 1 over 2 to the 5th power is, and then add 3 to that answer. Now remember, we already kind of did this piece in the previous video. When we had 2 to the negative 5th power, remember in example number 1, 2 to the negative 5th power, we got 0.03. Well, then if I add 3 to it, then I really should end up with 3.03, right? So that'll kind of save you some time when evaluating some of these, because we've kind of already did it. We just now have to add 3 to all of our answers. So I'm going to use the idea from last video, my numbers from my last video, and just add 3 to each of them. All right, hopefully your answers match mine, and we can go ahead and graph this function. We have a point at negative 5. Where am I? Negative 5, comma 3.03. 1, 2, 3, and just a little bit more, right? There we go. Oh wait, that was 5. That was negative 5, comma 3.03, sorry. Negative 5, comma 1, 2, 3, just a little bit more. Then we have negative 3, comma 3.12, just a little bit above that. Then we have negative 1, comma 3.5. Okay, I can do that. Negative 1, 1, 2, 3 and a half. And I can do 0, comma 4. And I can do 1, comma 5. 1, 5. I can do 3, 11. 3, 11, a little bit off my chart. And then I can do 5, 35, which is going to be way off my chart. And I can go ahead and graph my exponential function. Shoo, it's going to shoot up like that, right? Something along those lines. Okay, so let's compare our original 2 to the x with our 2 to the x plus 3. And how do you think that shifted or changed from our original graph in example number 1 to our graph now in example number 3 if we add 3 to the back? Well, kind of like when we did quadratics or parabolas, doesn't that shift our exponential function up 3? So if I can figure out what the graph of 2 to the x looks like, well then 2 to the x plus 3 is just a vertical shift up 3, kind of like our quadratic functions. Let's do one more. Make sure that it works for all of my values. What happens if I take my 1/2 to the x and then subtract 5? So I'm going to use my same values that I did in example number 2, but then I'm going to subtract 5 from each of my answers. Go ahead and do that and fill out this chart so then we can graph. All right, when I plugged in a negative 5 to my x, and then I subtracted 5, I ended up getting 27. When I plugged in a negative 3 to my x, and I had 1/2 to the negative 3 power, and then I subtracted 5, I got 3. I got negative 3, negative 4, negative 4.5, negative 4.875, and negative 4.9687 for the rest of my values. Let's go ahead and plot these points and see if our guess is right and if it shifts it down 5. I've got negative 5, comma 27, which is really far off of my chart, way up here somewhere, right? I have negative 3, comma 3, 1, 2, 3. I have -1, -3, -1, -3. I have 0, -4. I have 1, -4.5. 3, -4.875, so closer to -5, but not quite. I have 5, -4.96, so really close to -5, but not quite. And so kind of sketching this graph looks something like this. All right, did that take my original graph and shift it down? It looks like it did. It looked like it shifts it down 5 times, right? And so adding or subtracting a value to the back of your exponential function is a vertical shift up or down. If it's a positive number, it shifts it up. If it's a negative number, it shifts it down. So I can kind of look at a graph and figure out if the transformation is correct. Does it shift up? Does it shift down? And is it exponential growth or decay?